As earlier, we know that the relationship between pressure, density, and temperature, and also we knew that the relationship between pressure and altitude, density between uh, altitude and density, and also temperature be, changes with the altitude. Now we'll be learning about the atmosphere that obey the gas law, the relationship pressure, density, and the atmosphere. So air temperature, air pressure, and air density are all interrelated each other. If one of these variables changes, the other two usually changes as well. The relationship among the pressure, temperature, and density of air can be expressed by the equation which say pressure is equal to temperature time density time constant. This simple relationship we can say the gas law or equation of state. That equation of state tells us that the pressure of a gas is equal to its temperature times its density times a constant. When we ignore the constant and look at the gas law, it symbols something like pressure proportional to temperature and density. Of course, that P represent pressure, T temperature, and density. And it will be easier to understand the behavior of the gas if we keep one variable from changing and observe the behavior of other two. Suppose, for example, we hold the temperature as a constant. So what would be the relationship between pressure, air pressure, and air density? Assuming temperature is constant, so pressure will increase as density will increase. This expression will say that the pressure of the gas is proportional to its density as long as its temperature does not change. If the temperature of gas, such as air, is held constant, as pressure increase, the density will increase. As the pressure decrease, the density will also decrease. In other words, at the same temperature, air at a higher pressure is more denser than air at a lower pressure. If we apply this concept to the atmosphere, then we nearly the same temperature and elevation if we're talking the air above a region of surface high pressure is more dense than air above a region of a surface of low pressure. So we can see that uh, the surface high pressure area where we often being found anticyclone situation and surface low pressure area in somewhere in mid latitude we also call it cyclone. The air density mass of the air above these systems must change, as we will see in the later discussion that as well like air surface air pressure increase when the wind cause more air to move into a column of air than is able to leave, and the surface air pressure decrease when the wind cause more air to move out of a column of air than is able to enter. So we consider how pressure and density are related when temperature is not changing. What happened to the gas law when pressure of a gas remain constant? If we talk that, this relationship will tell us that the pressure of a gas is held constant, the gas become less dense as the temperature goes up, and gas become more dense as temperature goes down. Therefore, at a given atmospheric pressure, air that is cold is more dense than air is warm. We have to keep in our mind that the idea that cold air is more dense than the warm air only apply when we compare volume of air at the same level, where the pressure changes are small in any horizontal direction compared to the vertical direction. So we know now that relationship between among the pressure, density and temperature. We also know previously the relationship of pressure altitude, pressure density and temperature altitude. We already know now that the relationship of pressure density and temperature, what situation happen when one remain constant, what is the relationship happens in between.